do I? There we go. As promised from the end of class on Monday, we just finished up looking at the many different types of mimicry. So these are the 4 different types of organisms we looked at. And so what I want you to do is, given this sort of 2-dimensional graphic, is think about the relationship for the type of mimicry, that's our y-axis, and the strength of the poison for the type of mimicry that they're using. All right, so we have 2 different gradients we're looking at, weak versus strong poison, right? And fake versus real mimics. Okay, so it's not certainly going to be perfect as we go through this. We're going to kind of do our best to understand the relationship between those 2 things. So we've not done this kind before, but it should sort of let you drop the dots onto the graphic. It's kind of fun. Everything I need. You know what? Now I think it's Thursday. Not in the running for my favorite student this week now, are you? If we just all thought it together and then made the movement for it to be Thursday. There's nothing stopping us.
That would actually be super funny. Like, if you're like a senior and then you did that as like a senior prank, you just got everybody to act like it's a different day because it's the wrong class.
If you committed hard enough, there are certainly a few professors, myself included, that you could mess with for a short period of time convincingly.
I can give a whole lot show up. Like,
what are you doing, Dr. Arnett?
Yeah.
Where am I? What, 3 or 4 in line? let's take another minute or so to try to finish this up. I see that you guys still have your devices out, which tells me I think you're still working on this. I know that in my Bio 130 class, students are still kind of naughty and are monkeying around on their phones when we're done. I don't think most of you still do that, so if you are doing that, do me a favor and flip it down so I know you're done. I know this one takes a little longer because there's more to it. All right. So we have a couple of things that we really want to think about when we're looking at this. So let's try to take the individuals that we have in pieces here while we're thinking about this. So let's start by just looking at individuals 1 and 4. So as you guys noted, right, our individuals 1 and 4 here were our poisonous individuals from before. Okay, so our red salamander and our strawberry poison dart frog, that's my favorite one, I think it's the prettiest of all the poison dart frog family, are 2 poisonous ones. So we have noted that our strawberry poison dart frog, at least collectively, is more poisonous here. Why is that?
Poison from other poisonous people around, or organisms,
Very scary poison dart frogs. Exactly correct, right? So our strawberry poison dart frog is accumulating poisons from other organisms. Please forgive any horrific spelling since I'm kind of winging this as we go, right? Which was the alkaloid version, right? So basically upcycling, which we said that this was the more potent kind, right? So we did a really great job pointing out that this was stronger. Okay, so we should see that higher up on the poison side. Okay, our red salamander, slightly less poisonous. What kind of poison does the red salamander use? Or what was the gland type? Probably also horrifically spelled, that's fine. Okay, so this type of organism, right, is making their own, right, with kind of a sister to the mucus gland. Okay, also still poisonous, wouldn't want to eat it. It's not on my breakfast menu. Okay, but somewhat less concentrated. All right. So for both of these, okay, and it's fine, I'm not sure, it's difficult to say within the two, but we put these both in sort of this upper quadrant, right? Basically more towards the real version of mimicry. Okay, what kind of mimicry are these organisms more likely to be using since they're actually poisonous? Mullerian. Good. Okay, so remember Mullerian mimics. Okay, I'm poisonous, you're poisonous, right? So we're both dangerous and we're both going to look alike, right? So we can train our predators to just stay away from us. All right, so it's the real mimics. All right, so we definitely nailed, okay, our 1 and 4 organisms. Right, they're definitely in the right, gracious, the correct quadrant. That's easier to say. Switch colors here. Take a look at our number 2. Okay. Our redback salamander, is he or she poisonous? No, right? So we're in the correct quadrant. We could even imagine them being even further back, right? We have no poison. Okay, so very weak. Okay. Okay, what kind of mimicry? Batesian. Okay, so Batesian is under the fake category. So we have them in the right quadrant. Okay, and in this case, a particular kind of fake, right? We're faking poison. Right, so something like our redback, remember, is faking looking like a red salamander. I'm not actually poisonous, but I want to convince you, at least for a few seconds, that I am, so you don't eat me and I can escape. All right, this brings us to our great tree frog. He's kind of the weird one of the bunch. Okay. So we've got him even further down. This is good, right? So our great tree frog poisonous? No. Right, so also no poison. Right, is our great tree frog mimicking being poisonous? No, right? So we would almost imagine our great tree frog being even further down this list, right? What is our great tree frog faking?
He uses camouflage when he takes whatever place he is, so he can like hide from predators.
Exactly. In this case, right, our great tree frog is faking being a tree, right? But as Maria points out, right, our organisms that are using this type of mimicry are mimicking their environment, right? Not another organism. Try to move this here. Right, so this is, remember, cryptic.
I think it ended up in the middle because it didn't give us like, because it put fake TC on one side and the other.
Oh, I see. Well, in all cases, it's certainly in the right quadrant, right? I just feel like sometimes there's someone up there just like rolling around on the floor. Like I have no idea what they're doing above us. It's what it sounds like. Makes our projector shake and all sorts of crazy stuff. Okay, so being in this bottom quadrant, one way or another, we're faking it till we make it, right? We want the predators to leave us alone because certainly if they touch us, nothing's going to happen to the predator. Whereas if we're in this top quadrant, right, it's on the predator. We want the predators to still leave us alone because one way or another we're going to die. Okay, but in that top quadrant, we're actually poisonous. So if the predator touches us, the predator will also be punished, right? They'll get sick or die. All right, great job. Any questions about our very hot mess now graphic? I kind of like these. They never come out pretty, but they're always kind of fun. Oh. All right. Online, I know I've had a little bit of trouble with the camera, so as always, right, do make sure that you let me know if you have any questions by using your mic, but if I disappear or the screen does something funny, please make sure to chat or remind app or turn your mic on so I know that something's going on, because I'm a little nervous about it today. Oh, that's not helpful at all, is it? All right. I'm going to get that to go. My gracious. All right. So now that we've talked about that, the next thing I want to focus on is reproduction. And we've talked about this a little bit in the past when we've talked about amphibians, right? We've talked about, for example, internal fertilization in salamanders with the spermatophore, right? The leaving of the present. But we really want to focus on what exactly is going on here with amphibians, because they all do it a little weird. And they have very unusual and very interesting reproductive processes that set them apart from other organisms to some degree that we've seen now in lab, and we've kind of continued to talk about that makes them so unique. Okay. So the first thing we're going to talk about a little bit here is the process by which reproduction occurs. So the first stage in our reproduction that is interesting or unique is courtship. Okay. Now, we've had some female choice in the past. We talked about it a little bit with osteichthyes, but it was significantly more minimal. Okay, largely, oh, fish built nest, I choose fish, everybody goes up in giant ball, hopefully the male fish I chose is the one I end up with, right? Which is one of the main problems with largely external fertilizing organisms that mate in large groups. Here what we're going to see is there's a larger providence for female choice and much more single pairings, even with species that use external fertilization. And they have very specific processes that allow for, sorry, I'm stuttering today, allow for one-on-one pairings, even when they're using external fertilization. So female choice is much, much stronger. So the key here then, as the male, is to have some sort of method that allows you to grab that female's attention, right? Pick me, choose me, right? And of course, with any process, right, the end goal is fertilization of the eggs, one way or the other, whether we're using internal or external. Okay, amphibians are not lifelong partners, so we're just looking for fertilization at the ending of this breeding season. Although, as we'll see, some do nest guarding, so they may last the whole breeding season, but not past that.
But they don't do parenting, right? Because of the larvae.
Say again?
They don't have parenting skills.
Some do. So the question is, do they do parenting? And some do. So they may stay together or stay with the offspring through some larval development, but that would be as long as it would last. And even that is largely within the frogs. Okay, so whatever we've done to gain the female's attention, right? Some of this can be croaking, can be nest building, it can be displays. Most amphibians do some form of external fertilization. So most of our anurans, right, our frogs and our toads, and some of our salamanders. right? As we'll see here in a second, most of our salamanders will do internal. Even though we're doing external fertilization, okay, we're still going to have one-on-one pairings. Okay, so the giant mass, lay the eggs down, all the males show up and spray, and you're just going to pray that you are the one that fertilized them, those days are gone. Okay, so the way we get one-on-one pairings is a process called amplexis. So this is the image you see down on the bottom right here. Okay, so this is still external fertilization, even though this looks a little internal fertilization-y, right? So we have the female on the bottom. Okay, rule of thumb until we get to mammals, females are usually larger, right? Because the females have to make and hold all the eggs, and we need a bigger body to do that. Okay, the little guy on top, that's our dude. So the key here is this is basically a modified version of lay and spray. Okay, one-on-one lay and spray. So the female is still laying the eggs externally. Okay, so remember with external fertilization, the key is the egg and the sperm are meeting outside the body. So in this case, we have this pairing. This is amplexis. Okay, we're a couple now. So the female will start to lay her eggs in the water. And as she lays her eggs, okay, the male will also, is lay the right word? Spray? That just seems tacky to say. Puts out his sperm along with the eggs, right? So they are meeting outside the female's body, okay, basically as they're exiting her body and entering the water. Right, so fertilization happens here. Oop, that's definitely an E. So definitely external, but we have the benefit. Mom knows who the dad is, so she's gotten to choose. Dad is 100% sure he's the father. And if there is going to then be any parenting or nest guarding or any of that, right, we have two very specific contributed parents that now own that nest.
You look so unhappy.
I always think frogs generally look like very unhappy creatures.
When I was little, I caught two frogs during Amplexis and put like a bucket and like a rock, and then the next day it just all hangs all over.
Exactly. At least they finished.
Bucket, yeah.
So Noah ruined some frog's day. Is the end of that
I
story.
walked up on it and I was like, "What is this?" And then I realized it was two frogs. I was like, "Oh, they're both in the bucket."
Okay, so still external fertilization, right? But basically a big twist on it. Now, internal fertilization, we've talked about a little bit before. Okay, with our salamanders. One version that we've talked about, of course, is the present. Okay, what we've called spermatophores. Okay, so this is actually what we see here. These are all different versions of spermatophores. They're very hard to picture. Okay, but fundamentally, right, wrapped packages of sperm that the male is going to leave in front of the female for her to pick up. Okay, now the key here, right, is this isn't like, hey lady, here you go, right? We've gone through courtship, right? We're still a couple, all of that beforehand, right? And in many cases, we are still going to go through some kind of mating ritual beforehand, okay? And then the last step is, oh, okay, and then here you go, right? I'm going to leave my spermatophore for you. Drops it right in front of her face. This sounds very romantic. Okay. At which point she will go up, okay, and then sit on it with her cloaca, okay, accepting the presence of the spermatophore. And remember, this is internal fertilization, because when we're defining this, we're asking the question, where do the sperm and egg meet? And in this case, even though he's laid the sperm outside, right, the sperm will meet the eggs inside her body. Okay. So this is for most salamanders. Okay, a few of them do external, but most of them do this.
What's the like zoom in of?
These?
No, whenever it's like showing them like mating, not have that little bubble that zooms in.
This?
Yeah.
So that's this. So there are different courtship methods that salamanders can use. So quite literally mouthing or kissing around the head and gills if they have external gills. Right? Same kind of stuff that works in all organisms to put ladies in the mood.
What are Sicilians?
So that's the next thing we're going to talk about are Sicilians. Let's go ahead and these are very rare. I'll put these in pink. So Sicilians are legless salamanders, right? So they are a third order, and the one that we tend to think about the least because most of us have probably never seen them. Right? Most of us have grown up, we've seen frogs, we've seen toads, we've probably seen some kind of, well, you've all seen salamanders now, right? But we probably have not seen a Sicilian in real life. I'll have pictures here at the end, okay? To me, they always look like, if you've seen the live-action movie Beetlejuice, I think they look a lot like the sandworms in that movie. Hey, if you've not seen it, highly recommend ruining your life by watching it. Hey, but this is our third order. They're very rare. They're underground organisms. That's why they look a bit like worms, right? Because they're burrowers, so they have all that fossorial characteristics for us. These organisms are super weird, like start to finish. So they also do internal fertilization, being a salamander-like organism, but they're straight up going to have an intromittent organ to do this. Okay? And so their intromittent organ, that's what we see here, okay, everts, okay, meaning that it's normally kept inside their body, a bit like our snakes did this week. And then when it's ready to use, it sort of inflates. And it's called a phallodium. Okay, so this root here, we've probably seen once or twice before. The root being phallus, which is another word for penis, right? So we basically have an evertable penis that they use. Which works for them because they kind of have nothing else, right? They don't have any limbs or anything that they can use to get the job done. So this is up here, very teeny, a Sicilian. I have bigger pictures. It basically looks like a wet snake, but small. Right? They're only about yay big, and maybe about smaller than your forearm if you're online. Right? About that size, for the most part. They are nightmare fuel. Got to have one in every unit. So this is the one for this unit. All right. So we met our mate. We hooked up one way or another. I had successful fertilization. That's not what I want. And now we're ready to have offspring. So now we want to look at what that looks like. Okay? Just like with actual fertilization events, having of the offspring has a wide variety of variation as well. Okay, so of course the first of which we're very familiar with, right? Oviparity. Many, in fact most, amphibians do lay eggs, and there's actually two ways this looks. Okay, but remember that the key here is we're tied to water in some way, and this limits the way this can go. So in this case, right, we lay our eggs in the water, directly usually in some kind of water. And our babies are going to hatch and be born and have some kind of aquatic stage. Right? So this is what we looked at the beginning. Okay, so babies are going to have tails and gills and be tiny and cute. Okay, and so the key here, remember, as we compared amphibians to reptiles in lab, is that these eggs lack a shell. Right? They're not amniotes. Okay, so this keeps them tied to water. This means, importantly, that water and air and nutrients can pass through that egg continually while it's laid, okay, which means they can continue to grow and get things. The bad news means they could also desiccate, right? This is one of our worries as we move to land, is those eggs are going to be susceptible to desiccation. So we have to be really careful until we hatch. Okay, and then we have a second problem, right? Our babies are then basically fish. And our adults, not so much being fish, right? They have legs and are all hoppity or crawly or whatever is appropriate. So we need to make the transition from being very fish-like to being, well, not so fish-like. So this is what we see in our red box. Okay, now I don't care that you know like all of the super details here. Okay, what I do care is, generally speaking, that we have two compounds, iodine and T4. The T stands for thyroid, right? So it's a thyroid compound that gets released more and more as they grow up. Right, and the key here is, as these compounds are released, the same thing that kind of works with you, it's just not dissolving your body and making it a new thing, right? As you grow, you get more thyroid compounds. But the key here with them is they're going to dissolve some of their juvenile characteristics, these things being like the tail, for example, or the gills. Okay, and by dissolve, we really mean reabsorb, right? The tail doesn't just fall off and float around in the water, right? So a lot of these things, right, cells are very sustainable. So these tissues or these cellular materials, carbs, lipids, and all of that, get reabsorbed and recycled. In the meantime, we trigger growth. Specifically, things like legs, right? That will make them more successful. So they end up with, just like everyone else, very cute, mind you, but awkward teenager stages. Right? We got teeny useless legs and sad half-useless tails that make them kind of awkward along the edge of the water, where they are neither frog or fish, right? The pollywog. Okay, so we call this whole process, of course, metamorphosis, right? Literally, the changing or transitioning of one's whole body. Ah, I misspelled like 8 words on here, my gracious. Oh, we're good. Thought I heard a beep. Okay. So, we mentioned, however, that oviparity can look a little different depending on what kind of situation you're in. So you are tied to water to some degree, Okay, but there are tricks to dealing with it. Okay, so that first version is sort of the standard version. I'm a frog, I do my amplexus, I drop my eggs into an actual pond, they live their fishy lives for 2 weeks, right, or whatever. Okay, now, the problem, of course, is that's a very long time to be trapped in a pond and be a little fish, which is delicious and vulnerable, right? Being a tadpole is not an easy life. So one way we can get around this is called direct development. So I'm still oviparous, right? I'm still in an egg, okay? But the key for the most part is I'm going to skip the fishy tadpole stage. And I'm not actually skipping it, right? But what I'm going to do is, as we see here, aren't I cute? Is I'm going to stay in my little egg longer. And so all of my tadpole stages and the actual act of metamorphosis is going to occur within the egg. So my mom is going to lay me, instead of being in a pond, she's going to lay me, right? So freestanding water refers to actual, like, pools of water. Okay, so instead, I'm just going to be laid in a really moist place, right? Like puddles in a leaf. Okay, just enough that's going to keep my eggs moist. But since I'm not going to hatch out of my egg and need to swim around, I'm never going to be fish-like, I don't need an actual pool or pond. I just need to keep the egg wet enough that it doesn't dry out. Okay, so that's what we need by still needing moisture. Just something wet enough. Okay, because the key here is I'm staying in that egg. I'm going to stay extra long, okay, probably an extra week or so. I'm going to push through that tadpole stage, metamorphose, okay, pop out this tiny frog, or whatever, as appropriate. You know, this has a benefit and disadvantage to it, right? So my benefit here is I'm not going to need to be trapped in a pond. And I'm not going to be vulnerable to all of those animals, like fishes, for example, that think that tadpoles are very easy pickings, because a tadpole really can't defend itself in any way, shape, or form. Okay? What is my negative repercussion from taking this strategy as teeny frog? So I'm small, so I'm going to be very vulnerable when I first hatch to, like, insects. Okay? What else might be a downside here?
You're immediately competition to your parents.
I will be competition to my parents.
They don't have like updates, they skip that, they're in a step copy of their parents. So like whatever like evolutionary traits that a parent passes to their offspring, not gonna happen.
Well, we're still not clones. Right, so we're still eggs. So how long have I been in this egg for now? Like a long time, right? Okay, so this in and of itself is its own set of problems. Because I can't do anything when I'm stuck in an egg, right? I am super crazy vulnerable. The world is scary. So if a bee comes by, these eggs are tiny, right, and wants to eat an egg, they're going to eat me, okay, or a bird or whatever. So I am 100% vulnerable in egg form. And now I'm in egg form an extra long time. Now, this is one of the forms that we see nest guarding happen. Okay, but that's a long time to do nest guarding.
How long are they?
The eggs, it depends, but sometimes 2 to 3 weeks. right, and longer in this form than they are in the original form, right, because they're doing that extra metamorphosis stage. And that stage alone is usually something like 6 to 13 days, depending on the species. So there's a benefit when I come out, right? I'm more active and hoppy, but that egg stage is problematic.
So I'm like kind of confused still. So the first like the slide before this, do some amphibians use that, and then some use this like direct development?
Correct. Yeah. So the one before this is the standard way. So, most amphibians that use egg laying use this form.
Is it like called something else?
No, this doesn't have any special name.
No, they're called the same thing, but like once.
So this one is called direct development.
Okay.
So this one is special. It has a special name.
Okay. And so the second, like the direct development was basically like the next step to move.
Yeah, so it's more rare. Right, you're really only going to see it in really moist places like tropical rainforest. It has limited species that can do it in limited locations. Right, so we would not see this here, right, because we're not wet enough. We don't have enough places that they could do it. Yeah, so some places like Puerto Rico, you certainly could see this, right, because they have places like rainforests or wet locations that have species that could do that then.
It's really funny because it's not only like one or two eggs, it's like a lot.
Absolutely, right. And that's one, because these species tend to lay a lot of eggs at once. And part of that is because you know eggs are going to die. And the babies come out very cute because they're very small. Yes.
I almost killed a bunch one time. I was just walking, I didn't see them, and I started walking towards them, and you see all the little small frogs jumping. I'm like, oh my god, Cody! They're super.
Well, we'll get Noah in his bucket and put them all in there, and
I really thought you were going to throw a bucket.
this is little Noah. And
when you grow up around here, everybody has the same childhood. Like, it's what do you have to do for fun? Well, I got a bucket.
I remember picking frogs up when I was a kid. Mowing day was always the best, right? Because they would all come out of the woodwork and.
We would go into this creek and catch crawdads, and then just like let them go, and then catch them again, and then let them go.
We had like this nice rock wall at my grandparents' house. Always caught like any type of lizard that was out there. And that's where I found the two frogs. There was like a little stream of water.